Um, Good morning, everyone. Yes, that's what I was expecting. Thank you. So I stand between you and lunch. It's not a good position to be in, so I'll do my best to keep you engaged, and I hope that I work your brains enough so that you're hungry. So what you're going to hear today is a story. The typical hero story. There is a problem, there is a critical situation, and there is a solution. And the good news is the IM providers end up being heroes, the doctors end up being heroes, and the patients are the ones that are benefited the most. So everybody wins and nobody loses. That's the story. Thank you. So my name is Deepak Paramanand. I work for Synchronous. I'm a product manager there. And I am a doctor and I love Bluetooth is a quote from one of the doctors that used our system. And it's always a matter of great pride for us when one of your customers endorses your product, uses it every day, and is okay with sharing that quote for your own talk. So we're very happy to be presenting here. This is my first conference, and I've learned quite a bit. Hopefully, I add some value to your thought process as well. So this is the agenda today. We'll be talking about a bit of background of why I am speaking, of why Synchronous is here today. We'll talk a little bit about our challenges we faced and how we overcame them. And we'll also talk about analytics. That's my core focus. That's my bread and butter. I will talk about how analytics is helping the analytics and the identity space. We'll talk about use cases. I just went to Dallas last week, so I still am in that good, bad, ugly hangover. So we'll talk about a good use case, a bad use case, and an ugly use case, and see how analytics can help there. And once you see the system, you'll obviously think it's the next best thing to sliced bread. At least our doctors think so. But there are challenges in doing that, and we'll talk about the challenges. We'll also talk about a little bit of the architecture. This is the part where I get very excited. I've been told not to, but talking about how we can implement this system. We've done several proof of concepts, which I think are very, very unique, and how to get there. And then finally, wrap it up with benefits. They always say, end with the high, and that's the high I'm going to end with, as to why if you do this, what kind of benefits you'll get. So who are we? We're Synchronous. We work with 15 of the top 25 pharma companies. We're based in New Jersey, so proximity helps us. And so far, we've processed over 1 billion EPCS transactions, EPCS meaning electronic prescriptions for the state of New York and others. And we've, every day, because of the huge analytic infrastructure we process over 3 terabytes of data day to day. And the last point is really what I do. I do analytics, and those are the kind of analytics I do. I'm excited in doing this. So full disclosure, I moved to the identity product 2 years ago, so I guess which makes everybody here far more of an identity expert than I am. But my viewpoint is that how can I use identity and the data to make better authentication authorization decisions? And that's what I'm here to talk about. And today I'm here because we've done something cool for a large healthcare provider in the US, whom I cannot name. We have just rolled out a possession factor ability, and the doctors love it. Doctors are the ones suggested that we do it, and they love it. They're using it every day, and they're helping other doctors sign up and use that in production every day. So I'm here to talk about that. And the lead in, if you take nothing away from my presentation, if you take away one summary, it would be that the combination of IAM and a unique possession factor and analytics affects the most important person in a healthcare situation, the patient. Because we always talk about doctors and healthcare providers. What we really, really hear about is about patients. So we think that if the ultimate goal of affecting a patient positively is not met, then I think our solution has fallen short somewhere. And during the talk, we'll try to hopefully cover that chasm. So before we go into this, let's look at our current identity scenarios, right? This is the central question, who are you? And let's look at what have we done about that. So we say, who are you? We answer that based on what you know. We ask you for password, we ask you for KBA. We also talk about you, about what you have. You have an SMS, and you have a token. So that's what is there today. So what's going on? Where is the world going to? The world is going to this. Where are you? You know, the good old chat days, ASL, age, sex, location. Location is that important. So we're trying to find out who are you, where are you, so that we can uniquely define you better than ever before. And then lastly, what do you do? Because you are a doctor, you're a unique individual. We want to define you in the most unique way possible. So we want to make sure that you call your mom. It's the same number you call, and you listen to jazz today. You may want to listen to experiment with pop, and you usually run a mile. Some days you don't run a mile. We just want to make sure that with the combination of all these, we uniquely identify you. But ask the doctor, will he be pleased with giving all this information? I'm not sure. So the question now becomes, how can we in a least intrusive manner authenticate and secure what the doctor is doing so that the patient is affected positively in the end? So let's talk about the challenges in healthcare. I'm not a healthcare expert, so there are multiple challenges. I don't claim to know all of them, but I'm going to talk about the few that pertain to our problem. So if you see on the left there, that's the typical doctor work week. And in the summary, what you can see is 86% of the time, doctors work more than 40 hours a week. So they're overworked, and despite the overworking, are they spending quality time with patients? So the graph on the bottom will tell you only 27% of the time there is face-to-face interaction with the patients. So they are overworked. Despite being overworked, they are not spending quality time with patients. So now what can we do to solve that conundrum? Can we have them work less, or at least in a less stressful manner? Or can we increase the quality of interaction with patients? And on the right, there are us, we, the IAM providers. In my opinion, I look at us as the identity access middlemen. I think of us middlemen talking in between the doctor on the left and the patient on the right. The more in the background we are, the more securely we allow that transaction to happen, the more positively we affect the doctor-patient relationship. And we have our own challenges. We want to increase productivity and security at the same time. And for that, we use about 30 plus multi-factor authentication methods. And that's not good enough. We want to make sure that the experience is secure, but it's contentious. And then finally, if you provide that kind of security, it's expensive. Ultimately, remember, we want to affect the patient. The more expensive the solution, somebody has to pay the price. Typically, the patients do. So now, keeping these challenges in mind, how do we approach that solution, and what have we thought about it? So I'm going to define a factor, the possession factor. So starting from the left, moving to the right, here is how we look at it. So the traditional multi-factor authentication methods look at tokens as a non-living entity. You have a hard token, you have a soft token on a phone, it's a number. Anybody who has the number could be you. So we talk about it as a possession without individualization. What is the value of me holding the token versus somebody else? But if you change the paradigm to possession with individualization. So what I'm going to emphasize here is you with your token. Today we say you with the token. The token is given importance. What we're talking about is you should be given importance. It's you holding that token that makes you unique, and that assures your identity, which is what we talk about. And then we take that data and we analyze it. We look at what the doctor did, where the doctor was, and correlate that with the memory of past behaviors. Because an anomaly is a deviation from the norm. And if you remember the norm, we can always compare it with what's deviated. And once we do that, we have a secure yet frictionless system which is contextually authenticated. Again, two of the speakers before me have talked quite a bit about that. I'm going to take that topic and extend that a little bit further in the few slides. So I'm going to now talk about the use cases. Obviously, the first use case is a good use case. The sun is shining, it's a beautiful day, everything is awesome. And really talk about how we listen to the doctors more than what we listen to ourselves. So in product management circles, they ask us a question, which is the world's best product? And the answer is the ones the customers use, not the one we build. Because we could build anything. If the customers don't use, no point in it. Google Wave, remember? It was touted as the next big thing of decentralization. Died a death. Snapchat. Who would have thought people would love messages that expire within a day? Kids love it. So this is a use case of an EPCS system. So what happens in this case is a doctor is in New York City. He walks in and he wants to prescribe medication. And when he tries to prescribe the medication, the EPCS standards mandate that a second factor has to be checked before the prescription has been made. So this is the conflict, this is the failure, this is the suspense, and this is the success. So we rolled out, so what the doctor does is he walks into the hospital, and when he walks in, he enters his username, password. That's the first factor. And every time he wants to prescribe, we ask him for a PIN, social security, something like that. Or in some cases, a very difficult to remember 8-digit password. Capital. Yeah, he's already shaking his head. So that's exactly what the experience was. Doctors were like, no, I cannot call up IT every time I forget a password. You want me to call up IT, or do you want me to treat patients? So then they suggested that instead of having this, why can't you authenticate my device in a frictionless and yet seamless manner? So they suggested that they want to use Bluetooth. So what they said was, well, we'll have Bluetooth on our phones. We'll walk in with our devices, and based on proximity, authenticate us frictionlessly and let us prescribe. So this is now activated only when they try to prescribe. So that's the second factor check. They love it. They love it because they wanted it. And the system is in production. Doctors are using it today. It meets the mandates. And the best part is the product sells itself. We don't even have to have any marketing sales folks go talk to doctors. It's a word of mouth marketing. They're talking to other doctors saying, hey, you guys, you should use this because it's frictionless, it's secure. And so now what happens? Because you now have proximity check, your second check is passed, the doctor can now prescribe medication. The app can now prescribe. And the cool part is the doctor can now move about the whole hospital in a very frictionless manner. He can move from floor to floor, from patient to patient, just with the proximity check turned on, and he can keep authenticating. And what they say, don't change anything that works. But now analytics comes into play. Now, okay, it's good that you have Bluetooth on your phone. The question becomes, how do I assure the identity of the person having the device? How can I make sure it is Dr. John Smith and no one else? So what we're now doing, experimenting, I'll show you a proof of concept we have done, is taking attributes from the phone, from behaviors, from the prescriptions, and making sure that we are authorizing or assuring the identity of the doctor. So here are some of the attributes that we are looking at now. You have the fingerprint check. We're looking at a location check. You're looking at device check. And we'll be making sure that all these attributes together can assure the identity better. But that's not good enough. Let's say you have prescribed. What happens afterwards? Is the device stolen? Has it been hacked? What do you do afterwards? So we're not proposing that we keep data not only during authentication, even after authentication. Because we want to make sure that the person is not using the device or the ability to prescribe anomalously. During the post-authentication check may not make sense in this use case, but in the second use case, you'll see why it's important. So the key idea here to remember is that you need the behavior data from the doctor. You also need the transactional data. Now, when I say transactional data, because what you're really trying to track is Dr. John Smith prescribing a medication to the right patient? If he is he prescribing the right amount? Has he overprescribed? Now, we are meeting with resistance. Obviously, it's very, very secure data. Not all companies are sure that they want to give it to us. But because we've achieved success, we are having discussions to see how we can anonymize the data and still use it for what we want. So this is the good use case, right? And then typically you would follow it up with a bad. But I'm going to follow it up with an ugly. So the doctor walks in tomorrow and tries to prescribe medication again. But instead of the doctor, somebody else has their phone. So now John Doe has access to the phone. He tries to prescribe medication for Jane Doe. Then what happens? Ideally, Bluetooth proximity check should work because the device is there and he should work. Today, if this happens, we are in bad shape because we don't know who the device is. And that's why we're saying these kind of attributes make sense. Now you're asking the question, is the device being used in a biometric fashion? Has biometrics being used? Now, the moment I thought that was cool, I hear 3 kids on the panel saying we use biometric on each other's devices. I'm shaking my head saying, man, these kids are going to ruin my algorithm. I thought, why would anybody want to do that? But the question is, it's possible. Now can we use more and more biometric? I have the S8 Plus. If you have used the Samsung, the newest device, it has fingerprint, iris, face, pattern, and pin. Imagine how much doctors will hate us if we ask them to do all 5. It's going to be a tough sell. But then we have to assure the identity. Just having the device doesn't mean you are you. So in this case, the fingerprint check would fail. And what would happen? Obviously, the prescription would fail. We'll invalidate the user. We'll invalidate the prescription. And as a result of this, the doctor's access is frozen. A note is made, system learns and remembers. And as you can see here, because the prescription has not happened, you don't need to do the post-authorization checks because it's not important. But because something has failed, data is noted. Next time he tries to prescribe, we'll remember that device was compromised. So we could talk to the doctor and figure out what happened, either assign a new device to him, new SIM card, new IMSI, and then put it back into the system. We could do that. So this is the ugly. What about the bad use case, or the use case which typically happens? So just like us, doctors travel. Sometimes they travel from New York City, hop on a plane, and go to Seattle for conferences like this. And when they travel, they obviously want to consult. Now in this use case, it is the doctor, it is his device, but he's not in that location. Can we now look at a use case about what to do when he's not in the same location? So now Dr. John Smith, he meets with a new patient, he tries to prescribe a new medication, an opioid. Again, we like to check the Bluetooth proximity. Today it would pass, but tomorrow what you want to do is this. It's the same attributes, but depending on where he is and the contextuality, we're looking at different attributes. You want to look at location. You want to make sure that the location is the right location, and rather than simply allowing him to prescribe the medication, we're going to prompt him, right? So we're going to say that, you, Mr. Doctor, you're in a new location. We want to make sure it's you. So could you provide some additional information to assure us it's you and no one else? The doctor provides that information, system reads and understands that, and then as a result, a prescription is allowed. But think about this, right? Doctor is at this conference, 10 a.m., he gives a talk, 12 p.m., he tries to prescribe medication. He's had to answer a few personal questions, it's fine. What if he wants to prescribe yet again at 2 p.m.? Would you want to piss him off again and ask the same question again? No. You want to remember that. Discover any of the credit card companies, if you've used that, they remember you, they ask you, they prompt you for the first time, but you remember you afterwards. You want to make the same thing. We want to make sure it's you the first time, and after you do, we want to remember you. So now what happens is the system remembers that it's you, and the doctor is able to prescribe medication in the same frictionless manner. So this all sounds cool. This is how we're looking at the future. And we're actually working towards that. I'll show you a little bit of an architecture diagram and proof of concept. But we want to just talk about the challenges in this. Obviously, I've talked about a lot of data, and what are the challenges we foresee in making this awesome and workable. Data. Doctors, we have to get doctors on board. We want to make sure that doctors get access to the data. They give us data that they think is useful and usable. And we think we could do this because we've achieved success, because we were able to win them over with the Bluetooth. We think we can get access to that. The explosion of wearables. All I thought was a smartwatch was, I don't know what, a smartwatch may not cook for me. It could just tell me time, GPS, music, that's it, and that's a smartwatch. Now there are smart wearables. They detect your heartbeat. We could use that data to make sure you are the doctor, because your heartbeat is different. Everything about you is uniquely different than everybody else. We could use that data for assuring who you are. So there is an explosion of these variables that define you, and we have to make sure we are constantly aware of those technologies and make sure we can use them. And The cost of these systems, it's not cheap, because if you look at the analytics aspect, IM providers already have the infrastructure. It's the integration of analytics that's going to make it a little more expensive. But we see that in the longer run, it's going to make it far more usable. There is compliance. As you saw, we're looking at EPCS data. We're looking for patient health records. Will hospitals be happy providing us with that? We're not sure. It's an uphill battle, but we believe our intentions are noble in securing the identities of the doctors and the patients and assuring a truly frictionless experience. We think we'll have success in that. And if you ever sat with a guy from compliance, it's a very, very difficult conversation. I've had 18 meetings with him, and I think I have succeeded once maybe in getting the point across. And compliance is hard. You have HIPAA compliance, you have the data. What if your analytics system is in the cloud? What if your IM system is on-prem? How do you feed the data? Where do you keep the data? Are you going to encrypt data in storage, in transport, in usage? All those things exist. So there are much more challenges we faced. If I had to put all of them, you wouldn't want to see those. But here are the few challenges that we've seen. We still think that our end goal is noble, and we can succeed despite that. So next slide is an architecture slide. On the left, you see your typical IAM system. This is what they do. We have that working very well for us. But on the right is what we think we want to do. We want to look at analytics, and we want to look at data. We want to look at the location data. It's one example. You can look at behavior data, and most importantly, prescription data, because it's the combination of the doctor and patient we want to secure, not just the doctor in isolation. Then we model the data. We take the data in, we run it through various models, and make sure that we provide risk scores. The previous slide, when gentleman spoke about real-time analytics, this is the use case for that. You don't want the doctor waiting for 2 minutes to prescribe medication. At the max, he would like to have it 5 seconds or less. Because remember, he only spends 27% of the time caring for patients. You want to make sure that the quality is still increased. So how do we do it? So on the left again, there are the manual analytics methods. You have a lot of vendors here. You could talk to them and use them for analytics. But on the right is what we are doing. We are doing a proof of concept. It's called a adaptive neurofuzzy inference system. So in layman language, what it does is, it has these inputs. You can give as many inputs as you want, and the system decides based on prior behavior and comparison which of these attributes should be given the correct weightage for. For example, between me and him, he is a doctor who travels a lot more. So location attribute has a far higher weightage for him than for me. And let the system decide that. How much can you as a person have policies or roles for every single doctor in the system? It's hard. But if you have something like this, which is self-learning, you can do it piecemeal. Remember I spoke about the cost? What you can do is you could go live with a manual analytics system like this, whereas in the meanwhile, you could train the artificial neurofuzzy inference system to have attributes given to it over a period of time. You could start with 2 attributes, you could start with 5 attributes, see how the scores come up, compare it what's there in production. And once you think you've reached a critical mass where the scoring is right, for example, you want to look at a 0 to 0.5 risk score as to say disallow access and freeze access to the system. Between 0.5 to 0.7, you might say, something is amiss, assure identity using traditional MFA. But if it's green, allow access, and he can go about his business in the same way. So we've done a proof of concept with this. We have a pilot running. We have about 15 attributes that we ran. Unfortunately, it gave us really bad scores. So we are now pushing more attributes in there. The prescription attributes are very, very key because we want to assure identity of the transaction. It's a challenge getting that data, but we think that in a combination of the prescription data, behavior data, we should be able to get really high scores. And the cool thing is, it's self-learning. Models don't lie. Models don't have bias. We have biases. We feed data, we don't feed data, we have that bias. The models tell us exactly what's going on. So they can help us with that. If ANFIS is tough for you, I have suggested a few other ways to do it. You could use Watson API. I was talking to the IBM team yesterday. They gave me quite a good demo about what the API can do. You can use that. And I talked to the Google team. There is an API platform they call TensorFlow. they also can do that really, really well. There is a cool use case where a Google employee used the TensorFlow API platform to sort cucumbers for his parents back in China. They had a cucumber farm, and he had to sort the cucumbers which had thorns because these were high priority and highly sought after. So he used TensorFlow to recognize the images and sort cucumbers, and so that the manual way is reduced. Same principles can be applied for this to make sure that the system can learn from these attributes and provide risk scores. And finally, this Elasticsearch. This is what we use. They just launched their machine learning pack. They again read data from log files. You could use the same thing for analysis. So we spoke about challenges. We spoke about architecture. So what are the benefits? Why should we do it? So this system, again, has been in production for some time, and here are some of the estimates that we've seen work out. So remember the pie charts we had, 86% overworked, less time with patients. We see the benefits in 3 ways. You have less time authenticating, no remembering passwords, no calling customer care, just securely and frictionlessly do this. And you have more time for caring for patients. Your interactions are better. You don't have to be bothered about passwords. You can talk to them in a seamless fashion. And overall, I think the productivity of the doctors and the patients and everybody in the company, in the healthcare scenario, increases because of it. So what about us then? What do IAM providers stand to gain from it? We think we can provide a secure and frictionless experience, one which doctors love, one they'll use. And slowly and surely, we see this implemented across various healthcare providers. And the good news is that it could be small scale or large scale, depending on your appetite for risk, appetite for investment. You could start small with a small system with fewer attributes. And if you want to keep it more and more secure, you feed it more and more data, the model will tell you what the risk score is. And then finally, what are the benefits of getting it right for the most important person in the transaction, the patient? As I said to you, we look at ourselves as middlemen. We should be in the background. We shouldn't really be in front of the doctor or the patient. But at the same time, make sure that the job we do, the work we do, makes it very, very secure and frictionless for them. And so we believe that by doing this right, we affect positively the most important person in the transaction, the patient. So that's my talk. If you have questions and answers, I'll be happy to answer them. Both the mics are on.
How do you achieve EPCS validation for the DEA requirements for token validation, doing second factor in the manner that you're doing it? How do you get past the DEA requirements part of EPCS with the antiquated token validation requirements that exist?
Yeah, so so his question was, you can hear this. So initially, as I said, we had the good old method of providing a PIN and everything else, and that succeeded. But in this case, what you're saying is, because the device has the Bluetooth, the code that we run in the background already has the device stored and the information of the device stored. We are able to assure the identity based on the device and the proximity. So for example, you could have the device, but if you're not close to the system enough, you won't be able to do it. If you have the proximity, but any of the attributes of the device change, we will not be able to authenticate it.
And I'm saying that there are very specific requirements for EPCS, for token validation, that are mandated by DEA that are very clear and very restrictive, and I haven't seen how this can accomplish those requirements.
So I don't have a slide with me, but I can give you the details. I didn't want to bore people with all the specifications, but I can tell you that we have met the criteria and it's in production being used. And as far as I know, I think the system is in play with Impravata as well. I think the doctors want it from there, so they also have done this, something similar. So I don't have the details with me right now, but I can definitely provide it to you.
Question here.
Yeah.
How do you actually get the doctors or physicians to allow you to use their phone or even track their phone, especially non-employed physicians that might have a personal phone? Mm-hmm. I mean, most of our physicians say, you're not loading any crap on my phone. I'm not using my phone for that.
Because they wanted us to build it. They are the ones who pressurize us to build this for them, and they are the ones assuring that this will be used by other doctors because it's been successful for some of them. It's hard because you have this BYOD, either bring your own device or the device mandated by the healthcare provider. In our case though, the healthcare provider mandated that the doctors use devices that they had, so we could solve that problem. But in your case, it's a definite good question. We think that when we approach newer healthcare providers, we let the doctors speak, because we don't want to assume the doctors think the same way we do. We feel their pain and have the doctor speak to them instead. So it's a small price to pay. Ultimately, when you see the benefits, typically doctors come by.
Do they know you're tracking like what's in their, iTunes?
Not yet. So again, it's not in production yet. We are still evaluating. Again, that's a good question, because do they really want to know what music they are listening to? No. What we do is we don't care what music you listen to. It's the metadata we're bothered about. What we're really saying is, if it's the same song you've listened to every day, good enough. We don't care whether it's jazz or pop, Beyonce, Kanye, we don't care. Metadata has to remain same. What are the use cases where you'll revamp your entire music library in one day? If you do, it's not you. What are the chances of you revamping your entire contact history list in a day? If you do, it's not you. So we really bother about the metadata and not really the data about whom you're calling or what you're listening to.
Maybe I missed it, but can you walk me through the workflow for the physician? And the DEA requires 2 factors, right?
Yeah.
So proximity of the phone, possession of a phone is one factor. What's the other factor?
So when the doctor walks into the hospital, he has to authenticate himself.
Authenticate to what?
Into the system, into the hospital system, because the proximity is baked into the hospital system. So he walks in, he logs into the system, provides his username, password, and his identification, and he says that here are the 6 or 8 patients I'm seeing in these rooms. So all that information is there. So the proximity only works when, let's say, he's defined to meet 4 patients in those rooms, and the device assures the identity in those rooms based on proximity. But if the doctor goes to another room who is not supposed to see, he cannot prescribe.
Okay, thanks.
So it's very, very specific, very, very patient-doctor transactional based.
The initial,
Sorry.
just to answer your question, the initial authentication is either username and password to the computer system or a different token, a badge that's enabled to allow the user to log into the computer system. My question is related to the models. How do you validate the models and the decisions made by the system if it's all machine learning?
So we have a sense of, so again, the ugly use case we cannot track, because when fraud happens is only when the fraud happens, but the bad use cases we can track. For example, if you've changed location, if you've changed devices, the machine will output a score. It'll output a score of either, sorry, I'm just bringing that up. It'll output a score of either a 0.5 or it's usually 0.7 to 0.9. Now what we're saying is, because we are tracking the good use cases and the bad use cases, when the ugly use case happens, we'll be able to provide a risk score accordingly. And again, it's self-learning, meaning we feed back the actual result also into the system, and hence we are able to track it very well.
Well, I guess my concern is if a doctor is in a exam room with a patient trying to prescribe a prescription, and the system, he starts to do the prescription through the system, and the system says, no, you can't do this, he's not really going to get any feedback as to why his request was denied. And I don't even know if the IT team, the IT security team, could go back and explain to the doctor why his request was denied.
So two things will happen in the background. The risk score is generated. IT team knows why, because the attributes are fixed. The doctor comes to know that you have failed a device check or a location check. You are not able to prescribe. His access is frozen. End of story. On the background, the system knows why. They can get in touch with them and get that resolved because the attributes exist with them. Right? Thank you very much.